My name is Brendan. I'm an application support engineer at SRS. So I'll be emceeing this room for today and tomorrow, and I'm also presenting in a little bit. So I'm not going to, can everybody hear me okay? Yeah, so I'm not going to use a mic. Is that all right? Okay, cool. If I talk too fast or you don't catch my accent, let me know. I'll do my best to rectify that. So for the agenda today, obviously we just had lunch, seen some demos. I hope you all got around to see them. Then we'll have my talk, an introduction to srsRAN. We'll have Raphael with his talk and Ash with his talk as well. So just 3 today, and then we'll be back tomorrow with some more. We'll have a slightly longer schedule, a couple more talks, kind of building on what we're doing here today. So you might kind of be wondering why we have 2 rooms this year. This room is gauged more at, we'll say, more technical talks, and also talks from community members and people doing work with srsRAN. So that's people like Ash with kind of industry and startups, and then people like Raphael in academia. So you'll get a good mix, and maybe slightly less industry focused and maybe slightly less formal than the other room. So hopefully, these will be things that are interesting to you, and you come away with something. So first up, my name is Brendan McAuliffe. Like I said, I'm an application support engineer at SRS. I've been with the company for 4 years now. My main roles include the development of documentation, user support, some project management in some of our publicly funded projects, and also organizing this workshop. So if you have any issues during the rest of the running of the workshop, feel free to let me know. I'll be happy to help. And if you have any questions related to the usability or docs or anything like that, also let me know. So we'll get straight in. Okay, so an introduction to srsRAN project. This is gauged at maybe some new users, people that have been using the code for a little while and maybe want to try and understand a little bit more about what we're doing and how we do it. The goal here will be for me to tell you how we started as a company, how we got to where we are today in terms of the code and the product, and also a little bit about O-RAN and 5G and how we have gotten to that point, and how open source has gotten to this point, and how these things have all come together to become a very important part of where we go in the future of telecommunications. So here's what I just said in text form. So company overview, then we'll see what is 5G and Open RAN, what is open source, a little bit about srsRAN project, a little bit about developing an open source solution, which maybe is interesting to some of you, and then a small live demo. So the aim of the demo will be to, I guess, show you guys just how easy it is to create a private 5G network with srsRAN. It's not a perfect demo, so this is not a lab setup, but you'll see that when we get to it. Okay, so who are we and what do we do? You'll have seen some of this if you were at Paul's talk earlier, so I won't spend too long on it. But just to remind you all, so we are a private company founded in 2012. We're headquartered in Ireland. We have an office in Spain and Barcelona, which is where most of us came from this week. We have a global customer base, so Europe, North America, Asia. We have 24 full-time employees. At the moment, we are 100% software radio, and we are 100% organically grown. That means we have no investment, we have no angel investors or backing of any sort. So we are in full control of the business and the product, which is quite interesting and quite fun. Our areas of expertise, so we focus on 4 main things. So obviously software radio, it's in the name. Telecommunications, it's the product. Software engineering and signal processing. So all of these things come together to create SRS as a company and srsRAN as a product. So what do we do? We have currently srsRAN project, which is our main open source product, and srsRAN enterprise. But you may know us from srsRAN 4G, formerly SRS LTE. So that is srsRAN 4G is an open source 4G software radio suite. So it's a UE, eNodeB, and lightweight core. And srsRAN project is an open source 5G CUDU. Before I go any further, who is would say they are new to the code? Put your hand up. Okay, great. Target audience. This is fantastic. You've all come to the right place. Who's a little bit more experienced and kind of knows more about the code, has been using it for, we'll say, longer than 2 years? Okay. All right. Got a good mix. So hopefully you guys will come away with something today, and we'll learn a little bit more about the product. So yeah, what do we do? So where do we use the open source version? So srsRAN project, where does it get used? Beyond researchers and individuals that use it. So we're in a lot of publicly funded projects. So you'll see, does this have a pointer? Yeah, great. So these ones, kind of the ones that aren't in italic, are currently ongoing. And then we have these 4 that are kind of starting in the next couple of months. The SNSJU projects, they start in January, and Energize is in limbo, but it's starting soon, hopefully. So these are a wide range of projects. Anybody that works in publicly funded projects will know how this is. They're typically consortia of 10 to 20 partners, sometimes less than 10, all working to a research topic of varying TRLs. So you might have something that's very much experimental. You might have something that's very much implementation. And we fit into all of those. Within these, we work as a platform provider. So we go in and we give the code base and we say, hey, look, we're going to help you to use the code to further the research. We don't typically develop like crazy features. Unfortunately, we just don't have bandwidth for that. But this is a really good kind of proving ground for the bleeding edge of srsRAN projects. So the newer features as they come in are typically led by these projects. And this is how we test them out outside of obviously our own testing and integration, which I will talk about a little bit more later. Okay, and then some commercial engagements. So obviously we as a company, we don't just work in the public domain. We work with private contracts as well. So 2 of the more interesting ones, which if you attended Paul's talk, you'll know about. Smart Sky Networks, which is an air-to-ground private network for private jets. So that provides basically. They fit a UE to the plane. It communicates to a ground station. There are I think 300 of these across the US. The UE on the plane creates a Wi-Fi hotspot, so you can basically connect your phone to this Wi-Fi, which then uses our network on the ground to provide you with stable internet, not like the internet you would get on a Delta or United flight. AST Space Mobile. So this has been in the news a lot recently. This is a kind of first of its kind direct-to-mobile 4 and 5G network using the AST Space Mobile satellites, the Blue Walker, I think. No, Blue Walker was the test. Anyway, sorry, I can't remember the name of the actual product, but they've just launched their first 3, we'll say, commercial satellites, which will be providing the direct-to-mobile 4G and 5G connectivity. So our eNode B and GNode B are directly integrated into that stack for their testing and proof of concepts. Okay, so I've just shown you publicly funded projects. Open source makes sense there. And private projects, so commercial projects. Open source doesn't really make that much sense there anymore. So how do we work that? We have this kind of dual licensing approach where we have the open source srsRAN project, which is licensed under AGPL v3. And then we also have the commercial srsRAN Enterprise 5G offering, which is kind of licensed on a more kind of bespoke level. The contracts are created based on the product. These range from bespoke feature development to kind of support and stuff like that. So that is that. So now you know a little bit about the company, a little bit about SRS and how we work. We're going to take a little step back. We're going to zoom out and look at 5G and Open RAN. How did we get here? How do we get to these points? And why is it important? So why is it important for us as SRS? Why is it important for the product that we develop? So this might be bread and butter to a lot of you. It might be new to some of you. So what is 5G, right? We keep talking about 5G and Open RAN. What are they? What does it mean? So 5G is obviously a continuation of 4G, the latest standard of telecommunications. Sometimes called LTE, depends on where you are. So that the first release of LTE 4G was in 2008, release 8. Then we moved to 4G Plus, LTE Advanced, which was release 10 in 2011. And now we're at the kind of the first standards of 5G, which occurred in 2018. And currently we're at release 18. So this is obviously, we're building up, right? We're starting with these initial technologies, moving to more advanced technologies. And you can see that here, with the releases. So as we go through the releases, the speeds get higher, the latency gets lower. As society grows, the demands grow, so we require more internet and faster. Okay, so what is Open RAN? So Open RAN aims to define interfaces and components for 5G radio access networks. And these are the kind of the four main aims of Open RAN, right? So to promote interoperability, to reduce costs, to increase flexibility, and to enhance security. So this rings true with Open RAN and also open source, right? These things kind of go hand in hand. This idea of, as you open something up, you remove this kind of locking of, okay, there's only 3 players that provide equipment, that's what you get. As you open up these things and add more options for more people to come in and develop more products, you obviously need to make things more interoperable, right? It's the same for open source. As there are more eyes on the code, it has to work with more things because more people want to do stuff with it. It reduces the costs because there are more, like the cost to the cost of the consumer, right? There's more options, so people have to be competitive with their pricing. It increases the flexibility because you have more options to do more things. You can be more flexible with your use cases. It enhances security because, again, there's more eyes on it, right? More people are playing with it, more people are testing it, more people are breaking it, more people are fixing it. Also, when things are open, they just have to be secure and nobody wants to use it. So, we now know what Open RAN is, we know what 5G is. How have we gotten there from 4G? So you'll see here, and I'm going to go on this side because it's easier for me to turn here. Sorry to the guys on this side, they don't see the pointer as much. So this is the 4G network, right? Very much 3 small blocks. We then move with the ORAN functional splits to this kind of disaggregated architecture where you have the new 5G core, a CU, a DU, and an ORU. So this is a split 8 configuration. Split 7.2 does some more stuff down here, which we won't really talk about too much here because the configuration I'll be demoing will be split 8. Okay, cool. So that is very much, quite an elementary graphic of the ORAN architecture. Who's like extremely familiar with the ORAN architecture? Show of hands. Okay, a couple people. All right. So the logical step then is to break it down a little bit further, go higher in granularity. So it's more than just the GNOB redesign, right? This is a complete kind of new approach to how networks work. We're putting in things like the RIC, the non-real-time and near real-time RIC, right? So we're putting AI and ML directly into the network. We have a higher granularity of components in the tower. So this is not just, someone hasn't just come along and gone, hey, look, let's just put one new feature in. This is a complete redesign. So we have these new blocks, like I said, and some new interfaces, right? So there's a lot more complexity in the ORAN stack than what we had before. Right. Everybody should, at this point, thanks to this crash course, understand ORAN a little bit better. This will make sense in a second when we come back and look at, the srsRAN stack. Hopefully this diagram here will translate a little bit better for you. Okay, so what is open source and why is it important? As I've just said with Open RAN, there are a lot of reasons why it is important. The same holds true for open source, right? So open source refers to source code that follows these principles. This is kind of my interpretation, right? There's maybe more or less depending on where you stand. So free distribution, open access to source code, transparent development, collaboration among developers and users, and community-driven development. I think all of you here today will most likely agree with all of these, right? The code is free, srsRAN project. You have access to all of the source code. There's transparent development. That's why we're here, explaining to you what we're doing, what we've been doing for the last couple of years and what we're doing now in the future. Collaboration. We're all here collaborating. And a community-driven development. That's why we have these community talks, right? So why is this important? Again, like Open RAN, open source is vital for new and emerging technologies. Specifically in telecommunications, it's enabling innovation, interoperability, transparency, cost effectiveness, and flexibility and customization, all of the things we talked about, right? So this is why open source and ORAN go hand in hand. So who benefits from this? You might go, okay, well, like open source is great, but it's not always profitable. The code isn't always good. People look at open source and will say, oh, it's just not as good as the solution you pay for. It's not always true. So who actually benefits from open source? So operators, they get more flexibility in the code and in the products they have and can choose from. They have reduced costs. They have faster innovation. Then for vendors, there are more market opportunities, reduced costs, and there's a differentiation. Developers using open source code have access to the latest features. There's high collaboration between the developers using the code and the developers of the code. And there's a clear development process. So all open source projects will have a clear roadmap. Or some sort of roadmap. It may not always be clear, but at least there's something to go, hey, this feature is coming down the line. The end user, so that might be people like you here in the room, you get improved services and experiences. So typically, open source code actually works very well. Because it's open, because there are so many eyes on it, it has to work well or nobody will use it. There's a higher level of security, like we said, more eyes, more people breaking it, more people doing weird things, more people trying to fix it makes things more secure, and lower costs, right? Obviously, open source is free. Okay, so we've covered 5G, we've covered Open RAN, we've covered open source. What the hell does that have to do with the srsRAN project? Okay, so we started development on this back in 2021. So we had srsRAN 4G, we took the code and we went, okay, we don't need that anymore. Let's do a redesign, let's start from the ground up, and let's make the best product we can. So we worked kind of in darkness for about a year and a half, and then we had our initial release in 2023. So this was a kind of, it worked. It hadn't got the most features in the world, but it was a start. Then we've been constantly releasing and updating. We've had, at this point, 4 tagged releases. And then any of you that actively use the code base will know that we release every 2 weeks on a kind of a rolling, release schedule. So these main tag releases will have the big features, and then every 2 weeks we're doing bug fixing, smaller features, and kind of quality of life improvements for the code. So what does it look like? Like I said, we completely redesigned the stack from the ground up. So this area in blue, this is srsRAN project, right? And for you guys over here, it's there. And this matches up with the ORAN architecture that we showed earlier, right? So you can see we have the CU, which is here, which is broken down then into the CUCP and the CUUP. We then have the DU, which is broken down into the DU high and the DU low, and then we have the ORU. So those areas in gray, we don't develop. But all of the interfaces attaching to those, we do obviously have to have those. So the new code srsRAN project was designed with these 6 core tenets in mind. It had to be complete. It's completely owned by SRS. There are no third-party dependencies within the code. It had to be portable. So by that I mean it has to run on pretty much anything. So it does. You can run this on anything from a Raspberry Pi to a telco-grade server. It has to be performant on all of those platforms. It can't just be portable. It has to run and run well. It has to be open. That goes without saying. It has to be flexible. It has to work across various use cases. And it has to be interoperable. That is one of the core tenets of Open RAN. No, everything has to work together. You can't just have a CU that works with one DU. Okay, they all have to work. They all have to talk to each other. Okay, so currently what does srsRAN project provide in terms of features? So as of the latest release, we have the CU-DU split. So that means that previously this kind of blue block was one application, right? It was a monolithic G-Node B. Technically, the CU and the DU existed inside in that, but they hadn't been separated. The interfaces hadn't been opened up within the code. So now they have. So you have a DU application and a CU application. So in theory, if you wanted to take another DU or another CU, you can plug ours in. Great. We have 100 megahertz TDD and 50 megahertz FDD. We have support for 15 and 30 kilohertz subcarrier spacing, MIMO, 256 QAM, inter-G-Node B mobility, NTN support, E2 support. We have implemented our own custom open fronthaul interface for Split 7.2. So this means that if you're using a commercial ORU, not a USRP, that you don't need any external dependencies, right? In theory, our code will just plug and play with any ORU. I don't know, is anybody here using ORUs in their work? Okay, good. Yeah, it's weird. We still see a kind of a clear, like, or a 50-50 split between split 8 usurps and kind of split 7.2 ORUs. So yeah, there's room for both there. But we work well with both, which is nice. And then in terms of performance, we have kind of up to 64 UEs for 24 hours or more. And then 1500 megabits per second in the downlink and 200 megabits per second in the uplink. So, yes, sorry, go ahead.
Which slot patterns have you folks validated? The TDD slot patterns? You guys have 5 millisecond, 2.5. Does you have a number on your?
Andres here. He'll know the answer better than I do.
And we can wait also. I don't want to interrupt.
Yeah, can we get back to it at the end? Is that okay? Yeah. Okay, where was I? Anyway, yeah. Okay, so coming up, what do we have? So we have the, and if you were at Ishmael and Paul's presentation, you'll have seen this. So we do have a clear roadmap for what's coming down the line. CU-CP and CU-UP separation, so that is like a higher granularity here. So again, opening the E1 interface. You know, as we moved through the releases of srsRAN, the RAN will become more open, right? So we'll have this full ORAN architecture. Quality of service, so this is like slicing, stuff like that. Admission control, DRX, sending reference signals. O1 integration, so this will be support for non-real-time RICs, more E2, so expanding the E2 interface. Anybody who is developing and working with the E2 interface and near real-time RICs will know that that is quite a heavy lift. So we're doing our best to get those features out as quickly as we can. And then moving into 2025 and beyond, so we'll have FR2, carrier aggregation, massive MIMO, and lower latency. Okay, cool. So you know what srsRAN project is now, and you're going, how the hell do I use it? Where do I go? How do I get help? You know, how do I learn how to use the code? So we have two important resources, and they're kind of our two main Bibles, we'll say, to get through, you know, whether you're loading it up for the very first time or you're trying to do more bespoke use cases, do more research, and more kind of advanced stuff with the code. So obviously the docs, like I said at the start, this is my main responsibility as the documentation. So we're constantly updating that. We're constantly refactoring the docs and going back and looking at it and making sure that, you know, in the eyes of a first-time user, it's easy to follow. You know, that commands aren't broken and that the flow of work is logical. And we also have the GitHub discussion. So this is our kind of community-driven discussion boards. It replaced the mailing list. So anyone who used srsRAN 4G will know we had a mailing list for that. The discussions works a lot better. You know, it's a little bit easier for people to get involved. And we really do see this critical mass of kind of, you know, we don't have to do a lot of getting in there and answering questions because, you know, somebody from the community has already been there and already answered it. So if you're working with the code, you know, and even if you've just done something cool and you want to share it, we have a section for that. These user success stories, which we actually really like to see, because that helps us to kind of inform how we develop our documentation and what we're going to bring next. Yeah, and if you're new and you just need help, this is where you go. So it's kind of from our perspective, it's a little bit best effort, so we can't always get back to all of the stuff. But you know, if you submit something, somebody from the community will answer you. So what I'm just going to quickly break from the slides and just show you the documentation and show you the discussions for anyone that hasn't seen it. So if you're a brand new user and you're wanting to get set up with the code, it's pretty easy. You know, you just go to getting started, and then you can install the code. We have features that you can just hover over. You don't even have to click into the page. You can stay where you are and read it. But you know, you can go through a whole installation process. So just a kind of a heads up for the demo. I'm not going to go through this. I'm not going to go through the installation, but I will go through the configuration file and kind of running the code. So you know, you can go through this in your own time. Is out of interest, and you know, don't be afraid to put your hand up. Is there anybody here that has actually not run the code before?
Not what?
Not run the code, so not install the code and not run it.
This code?
Yeah. No. Okay. So for you, this is your place to go. Yeah, and you know, feel free to. I think my email's at the end of the slide, but feel free to, you know, if you run into any problems or you see, hey, this could be made better, let us know. Yeah, so within the docs, yeah, we have this like general getting started. It's pretty easy to follow, right? The user manual, developer's guide. So we have a little bit about software architecture with the kind of a higher breakdown of some of the applications within the functions within the stack. A coding style guide. So if you are reading the code or you want to try and contribute, that's where you go to kind of learn how we write the code. And then we have a knowledge base, which is a bit more kind of general, like ORAN understanding and stuff like that. We have a database of COTS UEs that have been tested. So if you have tested a phone, it would be great if you could check if it's on that list, because we do take submissions for that. So if you want to test it, if you've gotten a phone and you want to check if it works, or you have a phone that's not working, you can always check there. I can pull it up, and you'll see. There's a lot of phones here with some notes on the bands that they work with, the bandwidths that they work with, and some other stuff.
Each device has some different configuration file, right?
What do you mean, like each phone?
Each device will have different. These are I'm looking at also your tested costs UEs,
Mm-hmm.
and you have different bands or different settings that need to be selected.
Yeah.
For that device.
So testing with COTS phones is a bit of a dark art. So in theory, like the phone should work. If you look at the phone specs and it says supports bands, whatever, there'll be a list of all lists. They should in theory work in every single one of those bands, but they don't. A lot of it comes down to weird issues of security features that are baked into the OS. Sometimes when we bring phones from Europe for demos in the States, sometimes they don't work because the phones pick something up and it gets blocked. So that's why this list is super handy. So you can see that, okay, I know for sure that phone works in this band with this bandwidth with this PLMN configuration. So it's not that that phone only works with that configuration, because in theory it should work with any configuration. It's just that these are the ones that we know to work. And they're not just submitted by us, they're submitted by users. Raphael has actually submitted quite a few. I don't know if there's anybody else in the room who has submitted them.
We have this.
Yep.
I don't think it's on the list.
No, well, there you go. I'll be expecting a GitHub issue or a note at some point. Did that answer your question? Sorry.
Yeah, see that.
Yeah, perfect. Okay.
There's one on your list and I couldn't get to working.
Oh, really?
With me, so yeah.
Okay. Did you check even with the configuration that's in there?
Pixel 6, GB7, and 6.
Yeah, the Google phones are not the easiest to get working. Andre's your man. Ask him. Yeah, go ahead.
Has anyone ever played around with non-COTS UEs, so taking some other type of radio and loading some kind of software on it for it to act like a UE?
So you can actually use srsRAN from the 4G code base. It has some 5G capabilities. So yeah, I mean you can put srsRAN on a B210 or any sort of usurp, and then create a 5G network that way. You can use a Quectel modem and some other modems. Andre, are there any other ones that we've tested?
Microsoft.
Yeah, Microsoft UE. Yeah.
Any feature compliant.
Yeah.
5G is any UE stack.
Yeah. So in theory, anything that's a 5G UE should work with the stack. Any other questions on this? No? Cool. And then we have our tutorials. So these are kind of detailed walkthroughs of certain scenarios. So the one we'll be using in a second is the GNOB with a COTS UE. I guess this is like most people's first port of call for an application when they get up and running with srsRAN will be this, or srsUE. So we're going to go through this today. I'm not going to go through every single step in the doc, but the demo is built around the doc. So just one second. So if you want to reproduce it or you're struggling to follow along, feel free to pull up the web page and look through the doc as we're going through the demo. Yes?
You mentioned that the srsUE exists in the 4G code base. Is there other plans to implement 5G?
No, not right now. It's not something that's on our roadmap. Like I said at the start, we're 24 engineers. So to have a kind of a UE at the level we would like it to be, and also maintain srsRAN project, the CUDU, it's crazy. But if you want to give us a big bag of money, maybe we can talk. Was there another question over here?
Just follow up on, so that doesn't mean that srsUE
No, it can. Not so. Take this with a pinch of salt. So, srsUE works as a 5G UE, but as a proof of concept. You're not going to be able to do crazy tests with it because it was developed kind of towards the end of the srsRAN 4G development and the start of the srsRAN project development. So, at the moment we're maintaining it, but we're not adding a whole host of features to srsUE to make it more compatible. So you can do enough, like you can do an attach and send traffic, and you can do some stuff with it. Does it do MIMO? No. That was expanded. Piotr did some expansion on the UE, so it does have. But it's very clear in the app note. It's very clear on the conditions in which you can use srsUE and the CUDU. Like it's good to to get a network up and running, but you can't do too much with it. Anything else? No, cool, okay. So that's the docs. It has pretty much everything you need. And if at any point as a user you're going through this and you go, oh, you know what, it would be great if they had a document for this thing, or it would be great if they explained this a bit more, feel free to reach out to us. Email me, put something on discussions, open an issue. We're always looking for feedback, and that is one of the core things of open source, right, is that there's this kind of continuous cycle between the developers and between the users. So it's good to foster that as much as we can. Quickly then, the discussions. So like I said, this is where we go where users will go to get help. You can see these are all in bold because I haven't checked them in quite a while. I've been very busy organizing this. But you'll see here, there's a lot of users that are answering stuff, as well as Piotr, one of our engineers. You can see Andres there and David is there as well. So yeah, if you need help, this is where you go. Right, I think I'm just going to switch back to this. Oh, sorry. 1 second. Okay, cool, we're back. Right, so quickly just, because I do want to move on to the demo, and we're getting short on time. So developing an open source solution. We always hear about open source products. Not always, but there are a lot of open source products. We see them a lot, but I guess people on the other side of the wall don't always know what it's like to develop an open source solution. Now, I will caveat this by saying I am not one of the main developers. I do develop a little bit, so I will do my best to give you a good idea of what it's like. But as someone working more on the user side, I have a fair idea. Maybe Andre can chime in with something. Andre is our VP of engineering, so he obviously knows exactly what it's like to develop an open source solution. Right, so how does it work? Like I said, we're a team of 22 engineers developing basically full-time. Yeah, so sorry, there's 3 main teams. So we have development, obviously, we have testing, and then we have integration. So this is like, integration with RUs, RICs, phones, platforms, architectures, all that kind of stuff. So everything is written in C++. We have some MATLAB for testing, specifically around the physical layer. And then we have some Python for testing and scripting. But the code that you guys are using is mainly C++. Right, so the main languages are all up here. So we have C++, like I said, that's the main coding language. CMake for the build environment, MATLAB for testing and prototyping, Python for the CI/CD and some emulation, and then we have Bash for some of the scripting kind of within the testing framework. In terms of the tools we use, so we use Git. That's where you guys, GitHub, that's where you get your stuff. We have GitLab for the CI/CD, Kubernetes for some stuff, Docker, GDB, Valgrind, Google Test, and ASN and TSAN. Okay, so, in terms of developing an open source product, developing any product, CI/CD is your most important step. And it's something we spend a lot of time on. And it's what allows us to, create code that works. Everything that goes out into the open goes through this pipeline numerous times at numerous different stages. Okay. So in terms of releasing the code, so how does it work? So like I said earlier, we push an update to GitHub every 2 weeks, roughly. And we have tagged releases twice a year. So once at the end of April and once at the end of October. So that's why you'll see, 2304, 2404, 2310. The first 2 digits of the year, the second 2 digits indicate the release month. And so before each release, there's a freeze. So this is a feature freeze. And the release candidate must pass strict testing and conformance requirements. So this is within the CI/CD pipeline, and also with some manual testing. The documentation, that's updated regularly, so there's kind of no fixed schedule for that. We just put things out as we need them. There'll be a month where we have something out every week. We might have a period of time where there's something out, only once a month. But we do have larger updates with tight releases. So that'll be like new tutorials and stuff like that as we have new features that come online. So I guess this is more from my perspective. But also as an open source product, right, and project, you're only as good as your usability and your documentation. We could have the best code in the world, which some might say we do. But if our documentation was crap, it wouldn't work and nobody would use it. So it's essential to the user experience. In terms of creating the documentation, it requires a deep understanding of the code and what it does. Yeah, that's something that you need to lean heavily on your engineers for, because they always know more than you do. We rely extensively on internal documentation, so we're always writing internal guides for ourselves. Those eventually become the dev guide entries and some tutorials. And then we aim to make things as simple as possible. So you'll see in our documentation, like it's quite succinct, and it doesn't go into too much detail unless it has to, right? That's because we don't want to overwhelm newer users. If you're, 10 years into your development career, you're well able to take open source code and run with it and create new features. If you're, in university or just starting in industry, you need a little bit more help. And those are the people we need to focus on, because if we can't get new users in, we don't have this kind of cyclical nature with getting people in and people helping us to progress the code. It's not easy to do that. We can't cater to everybody, so there are occasions where, yes, we have to assume some understanding in newer users, or we just can't go as far as we would like with the more experienced users, because it's just too hard to document. It grows legs and becomes quite a large scale thing. And then also community-driven support. So this is really important, right? Because we don't have time to get back to everybody. So if we can create good documentation and good usability, it helps to create community support because other people know how it works. Also, it's nice for the community to learn from other people, and when we see community members answering questions, that sometimes helps us to create more resources. Okay, so how do we make the software usable? So we have easy-to-use configuration files. If you use the code, you'll know about that. We have easy-to-read console outputs, so that's this in the blue box up here. We also have a pretty intuitive GUI based on Grafana. There are a large array of layer-specific logs that you can enable or disable as you need. There's also layer-specific PCAPs, which you can enable and disable as you need. And we don't require specific hardware. So this code will run on pretty much anything. You don't need special equipment. Right. Questions? Anybody?
If you don't require specific hardware, how do you guarantee the performance then?
What do you mean?
Last there was like, doesn't
Yeah.
require specific hardware, right?
Yeah.
How do you guarantee the performance of the software?
So obviously we test on a lot of different platforms, so we know that it performs well, but also the configuration file allows you to configure a lot of the physical resources of the application. So for a Raspberry Pi, there are things you can do within the config that allows you to become performant on that platform. Likewise, for putting it onto a commercial grade server, you can unlock more within the configuration file in terms of more performance to make it performant on that.
So is that all documented then in that document?
Yeah, if you look quickly, let me go here. So we have this configuration reference, right, which is a massive file, and it explains all of the configuration options along with default values and kind of what they do and the supported range of values that you can use in that field. So the best thing is to go through this. We don't yet have a document specifically on performance tuning for platforms. That's something we're working on, but it's extremely difficult to do because there are so many guess, factors that influence. Yes, you might have a certain CPU, but it also depends on how do you cool it? Is it plugged in? Do you have other things installed like DPDK? It's very hard to just create a kind of a one-size-fits-all tuning guide, we'll call it. But if you have specific questions about a specific platform, we can maybe help you with that. But in terms of just making it performant and guaranteeing performance, this is what does it for us. Did that answer your question?
Yeah.
Yeah.
So do you have a list of like recommended platforms or something?
No, because again, it's extremely subjective. It depends on what you want to do. Like we could tell you, yes, this certain laptop will allow you to do exactly what you need to do for your use case, but that might only hold true if you're using certain phones and certain hardware. We can't guarantee you performance, or that we can't guarantee you that that platform will be performant on all of the things you want to do. So that's something you kind of have to decide for yourself. If you're getting to that point, then we kind of have to assume that you know what you're looking for with that. Anything else? No? Okay. We're a little bit short on time, but I think we'll be okay. So I am going to do the demo, if that's okay with everybody. Yeah, cool. If anybody thinks of any questions, just feel free to stick your hand up. Okay, cool. So just a quick rundown of the demo. So this is going to be, like I said, COTS UE with srsRAN project, the G0B, Open5GS as the core, and then with access to the public internet. So in terms of software requirements, obviously, srsRAN project. The Docker for 5GC, that's a little bit of an error. We're actually running the core on bare metal. Influx and Grafana, so this is for the GUI. And then in terms of the hardware requirements, obviously a PC with a Linux-based OS. We don't support Windows or Mac. A USERP, in this case it's a B210, and a 5G capable COTS UE. In this case, it's a OnePlus 8T. Right, so following the documentation, we need to do the following. So we need to configure the G0B, so I'll walk through that. We need to program the SIM card. I'm not going to do that. The SIM is already programmed inside in the UE. We need to configure the core. Again, that's already done, but I'll quickly show you the core interface so you can see where it is. And then configure the UE. Again, it's already done, but I'll quickly go through the settings and show you what we've done. And then, in theory, it should connect. Anybody that's run this themselves will know that UEs don't always connect. But in this case, I promise you it does. We've tested it already. Okay. So then we have it set up, the phone is connecting, everything's going great. What can you do then? Because it's kind of like, okay, yeah, it's pretty cool, the phone works, but what can we actually do with it? What can we do with the code to maybe change things a little bit? So via the configuration file, we can, and by the command line in some cases, we can optimize the RF link by changing the RX and TX gain. Joachim had a talk in the other room about this, which will be recorded, so you can look at that later. I won't go through that too much now. But there are ways you can go in and fine-tune this a little bit more than what I'll show. You can modify the configuration, just change random things, see what happens. In this case, we will modify the MCS and the QAM. You could browse the internet, just Facebook, Instagram, TikTok, whatever you want. And then we could connect multiple UEs. So unfortunately, I can't show you that today. But you can connect any number of UEs. I saw a demo upstairs from the guys at CCI with something like 8 UEs. In theory, you could do, 64 or whatever you want to do until it crashes. Okay, cool. It's not the end. So I'm going to just pop out of this for a sec so you can talk amongst yourselves. And then we're going to go to this. Okay. So this is the configuration file for the G0B. Can everybody read that? Is the text big enough? Yeah? Okay, cool. So quickly, for anybody that hasn't seen it, at the top, we are configuring the interface for the core. Then we have the configuration for the SDR, the cell, the logs. We're turning the logs off. I don't recommend you do this, but for the sake of performance, because everything's running on a laptop, that siren's very annoying. We turn the log off so that it runs a little bit better. And also the metrics are being output to Grafana via this configuration here. Then, so one thing you can do with the code when you run it is you can append multiple configuration files. So I will append, after the first run, another configuration file that will set the MCS. So we can see how easy that is to do. We can then see what that does to the performance. And we'll also mess with the QAM and see what that does. I said at the start that this is not a perfect demo. That's because when I do this, it will probably crash because the laptop can't handle it. But we'll see. We'll see what it does. Gonna see, is there anything else? Yeah. So just a basic rundown on. The core. You guys want to see that? So here, this is the Open5GS UI or UI. Sorry. And you can see here that the SIM is registered. Down at the bottom, one of the most important steps and something that catches a lot of people out is we define the APN. And you have to make sure that the APN is exactly the same across the UI and the core. If not, you're not going to get a PDU session and you won't be able to access the internet. You will connect to the network, but you just won't be able to do anything. So if you are getting a connection in your own testing, but you can't get internet access, it's most likely something here. Okay, cool. Any questions on the configuration?
You just mentioned you're running the core here now.
Yeah.
This is the core, right?
Yeah. It's just running in the PC in the background. Yep.
I have a question.
Yes.
So you're using the 78 band, right?
Yep.
So you don't have a conflict with like T-Mobile or Verizon?
No, it's a piece of empty spectrum. So yeah, we won't dwell on that. But it's a usurp. It's very low levels. So and we're only going to do it quick. So we're not hanging around in anybody's airspace for too long. Any other questions on the config? Nope.
The SIM, is that just a text file?
The SIM, no. So the SIM is a hard SIM in the phone.
I see. But for you to put the key material for the core for the authentication, you have to have that key material put in.
Yes. Yeah. So I can show you the SIM. They're all out. Here's this one here. So the SIM is like a little, like a standard SIM, right? From System.com. So when you order these from System.com, you get a spreadsheet with all the information, and you just input that into Open5GS. You do have to do some coding. You have to turn some features off, but it's all in the doc. Okay, cool. So I'm going to do this quickly because I'm eating into Raphael's time, and then I'm eating into your coffee break later on. You'll see the G-Node B is running in the terminal on the left, and then on the right, I have a live feed of the phone so that you guys can see what I'm doing. So quickly, nothing is going to be running right now, but sorry. So just so you can see, so the SIM card is there in slot 1. And yeah, we've data roaming enabled. And then the preferred network type, you'll see this isn't selected because we've used an application to force it to only see 5G networks. Again, this is in the documentation. And the access point is set to internet, right? So this is the APN that's in the core. It's exactly the same, so that we don't have any conflicts. I'll quickly show you. We use this 5G network application to force NR only. That means the phone is only looking for 5G NR. It's not going to try and pick up any commercial cells that are around. And that's it. You can see some of the details of the SIM. Yeah, cool. Okay, so we're going to put this in airplane mode and then quickly run the G-Node B. I'm going to start the trace, and then I'm going to turn off airplane mode. And it should, like I said, just connect. We'll give it a second. I swear this worked an hour ago. Oh, God. It's like when it's not your phone, it's hard to work. Okay, so sometimes you do have to mess around with it. See, the great thing about this is if it doesn't work, we can edit from the video, but you guys are all going to know that it didn't work. in here. No, we're in our only. Ah, see, you get to see live debugging. This is like more than you signed up for. Oh, yay!
So you didn't have to rely on that 5G switch app.
Not always.
Yeah.
Not always.
You just did it manually from the phone set.
Yeah. So sometimes when you do this, you'll see it does all of, so it's doing 4G, 3G, and 2G. From the app, you'll see when you use the app, the selection no longer comes up.
Right.
So it's only doing 5G. But again, it's all explained in the doc. So we're going to quickly do a speed test. And you'll see we did one before, so it did work. And so you can also see on the trace. So you'll see that, you'll see here, right, in the uplink, we're getting this overload. So that means that there's something wrong with the RX gain. So what we're going to do is, and we can do this all on the fly. So I'm going to disable the trace, and I'm going to type RX gain 0, so port 0, and we're going to set it to 45. So right now it's set to 70, all right? So I don't have to reset the G-Node B. This has automatically updated the gain values on the USERP, and I don't have to reestablish the connection with the phone. So you'll see that we got, like, I think is it 2 megabits per second on the uplink, which is quite low for the 20 megahertz cell that we're using. And we know something's wrong because of this overload. So we'll lower the RX gain and run the speed test again, and we should see an improvement in the uplink, provided the phone stays connected. So let's see.
So if you type help there, you will see other commands.
Yeah, so we have, like, it'll print out an update of the RU, or so the conditions of the thing. The conditions of the front end, and then yeah, you can get more help with other things. You can also change the TX gain, similarly to how we're changing the RX gain, but it's kind of recommended to always leave the TX gain at the highest value. So let's see if this will work. Oh yeah, sorry. Here we go. So you'll see that we're no longer getting an overload here. And what we're looking for is a value as close to 0 as possible, okay? So this tells us that the uplink quality is better. So when we run the upload test now, we should see a vast improvement, if it'll work. Yeah. It's likely that there's some interference in this band, so we may not get it to work. Yeah. Oh, yeah. Maybe. Yeah. Is it running? God's sake. Okay. That might have been it. I'm gonna cycle this through again. Okay. See, this is why we do these demos in this room and not the big room, so that we can get away with having small technical hiccups. Okay.
I'll take the blame for jamming it.
Yeah. A targeted attack.
It's like highly targeted.
Yeah. Okay. Yeah, I mean, I could stop the demo and you could have to take my word that it works, but we'll do our best to show you. Okay, here we go. Yeah, so you see a massive improvement in the uplink. Yeah, I think it's crashed again. But anyway, it worked. It only had to work once, single use. Okay, so what was the point in showing you that? The point in that is that it's super easy once it works and if it's stable to go about changing configurations within the setup. There was some more stuff I want to show you, but I'm not going to do it because I'm really cutting into Raphael's time. I have been very bad and very selfish here, going over time. But that's what you get to do when you run the room. Okay, great. Does anybody have any questions? Yes.
I thought I saw that you have the MCS to 10, but I see a higher value.
No. So that would have been the next step of the demo would be to kind of cap the MCS and show you what that looks like. But yeah, at the moment it's an adaptive MCS, so it gives you the best possible MCS given the conditions. And this is all kind of done within the code. Great. Okay, any other questions? Hopefully you've all learned that the code is extremely usable. You have a better idea of how we got there and what we're about. Final call for questions? No? Okay, amazing. Well, thank you so much for your time. I hope you got something out of that. Sorry, Raphael, 1 second. So I am going to finish up. Thank you very much. If anybody has any questions, feel free to grab me either this afternoon or tomorrow. My email is just brendan@srs.io. If you ever want to get in contact, feel free. Yeah, that's it. Thank you. Okay.